Hello everyone. Today we will discuss about the verification of the truth table of 4x2 encoder using virtual lab. So in the previous lecture we have discussed about the 4x2x4 decoder. Now this is 4x2 encoder. First of all we will discuss about the encoder. What is encoder? So let's start about it. First of all, an encoder is a combinational circuit that performs the reverse operation of the decoder. Means because in the decoder we have seen already that n input and 2 to the power n output. But here it has maximum of 2 to the power n input lines and n output lines. Just reverse, just opposite. Okay, here we can see that this is the truth table of the encoder 4x2 which is required to do the verification of the truth table in the virtual lab. So first of all we have to know about the truth table and how it will work for 4x2 encoder. Okay, first of all we can see y0, y1, y2, y3 and a0, a1. y3 to y0, these are the 4 inputs, and a1 to a0, 2 outputs. First of all we can see that 0, 0, 0, 1 means when y0 is enabled, no outputs are enabled. So the enabling of the y0 is not working at all because the outputs are 0. Okay, then in the next line we can see y1 is 1 and here a0 the output is also 1. So it will work. After that y2, and in the output section a1 is 1, and when the last one y3 is 1, then both the outputs are 1, which is a1 and a0 both are 1. So we can form the equations like a1 equal to y3 plus y2, because wherever a1 is 1 we can take the inputs y2 plus y3. We can see in the truth table in the third row that a1 is 1. In the fourth row also the a1 is 1. So y2 1 and y3 1, then only a1 is 1. So y3 plus y2. You can write y2 plus y3 also. Then a0. In a0 section we can see in the second row and fourth row it is 1. So we can take y1 and y3. Here we can check that a0 equal to y3 plus y1. So I think it is clear to you. Now we will shift with the virtual lab. In the Google we will type the virtual lab, then this window will be opened, and then we will select the digital electronics lab new. Okay, after that list of experiments. Here we can see in the 8, number 8 is the implementation and verification of decoder, demultiplexer, decoder or demultiplexer. We have done this already with the decoder, and now we will do encoder. So we will click on the encoder section. Now simulation. Here we will select the encoder. So as we have seen already that y0 is not working at all on the outputs, so here y0 represent d0, so d0 is not connected to the OR gate. Okay, this is connected to d1, d2 and d3. d1 is connected to 2 input in the OR gate, d2 is connected to the 2, d1 1, d2 2 and d3 is connected to the 5. Okay, 3 and 6 is the output, which is y0 and y1. Here y0 and y1 are the outputs. Okay, first of all we will on the power supply, which is VCC plus 5 volt. After that we will on the D1. Then we can see y0 is 1. After that if we off D1 and on the D2, then we can see y1 is 1 because the LED is glowing. Okay, here also this is added. Okay, then D1 and D2 we have already selected. Okay, then we will off the D2 and select the D3. We can see both the LEDs are glowing, and in the truth table also here D3 is selected and y1 and y0 are 1. So the verification of the truth table has been completed. So thank you for learning with the patience, and please subscribe our channel.